So this is the remaining part of part A. Now let's head to part B, 37B. So which says Vx0 is V cos 7 degrees and Vy0 is V sine 7 degrees. Why? Because the launch angle of V is 7 degrees. So the x component of the velocity, or the initial x component of the initial velocity, is v. Let's not call it v0 because it's always been v, so let's keep it v. So v cos 7 degrees and the y component is v sine 7 degrees. So let's start with the delta x equation as we did in part A. So Vx naught, delta x is Vx naught times t plus half Ax t squared. Again, Ax is 0, there is no acceleration in x direction. So delta x will be Vx0, which is V cos 7 degrees times t, or 22 meters equals V cos 7 degrees times t. Now from here we can find an expression of t as a function of v, which is 22 meters divided by v cos 7 degrees. Now let's leave x part of the equation here and go to the y part of the equation. Delta y is Vy0 times t minus half g t squared. So half g is half times 9.8, which is 4.9. It's easy if you remember this, then you can skip one step. So I will just write over here Vy0 times t minus 4.9 t squared. So let's substitute Vy0, which is V sine 7 degrees times t, which is 22 meters divided by V, let's take this equation to the right side. I'm running out of space, so let's delete this part. So we already know that t is 22 meters divided by v cos 7 degrees, which we got from our x equation. Now delta y is Vy0 times t minus 4.9 t squared, which is V sine 7 degrees times t, which is 22 divided by V cos 7 degrees minus 4.9 t squared. Now v are cancelled from numerator and denominator, and we are left with sine 7 degrees by cos 7 degrees times 22, and we know that sine 7 by cos 7 is tan 7 degrees times 22 minus 4.9 t squared. and this delta y is nothing but negative 1.5. So again, it's the calculator thing. We will take this to the right hand side, bring this to the left hand side. There will be a change of sign. So let's delete this part as well to make some more room. So your 4.9 t squared equal to tan 7 degrees times 22, tan 7 degrees times 22 plus 1.5, which is again you have to use the calculator, which comes out to be 4.2. Then t squared is 4.2 divided by 4.9. Then t is root over 4.2 by 4.9, which is your 0.92582, 0.92582 seconds. So this is my time. Now after finding out the time, we will plug it back into the x equation and find out the velocity. So let's do that. So v cos 7 degrees is 22 meters divided by t, which we already know because v x0 t is, or we can say v x0 t is nothing but delta x. We already know this. So this equation comes from there. So my t is this value. So 22 meters divided by 0.925825, and v is therefore 22 divided by cos 7 degrees times time, which is 0.925825, and again using the calculator, this value comes out to be 94 meter per second. So for leaving the ramp at 7 degrees with the horizontal, the car needs a velocity of 23.94 meter per second to clear the 22 meter distance.